Hi, I would like to continue talking about factoring, and let's look at some special factors, and we'll have some different situations that I'll show you with the help of my friend Euclid, but I'm going to have to duck. Here's our first situation. We have the difference of squares. Now, if you factor the left-hand side, you'll get what's on the right-hand side. Now, let me give you a specific problem here involving this. If we take the square root of each of these terms, in this case we'll get 2x and 1. This is our a and b. Substitute those in the right-hand side, and we'll get the quantity 2x plus 1 times the quantity 2x minus 1. So if you take the difference of squares, this is what your factoring should look like. So let's look at this next problem, which is like that. It's the difference of squares. Take the square root of 25, you'll get 5, and the square root of a square, b squared, and we'll get a is 5, and b will be ab. And so your factors will look like the previous example that we had here, because it's the difference of squares. So I think I see Euclid coming again here, so I have to duck. Now, this situation here is where we have a perfect square. The left-hand side is a perfect square of the right-hand side. So let's take and look at a problem that deals with this sort of thing. What we can do is take the square root of 16x squared and the square root of 25. So our a and b this time will be 4x and 5. And notice that the factors are the same because we have a perfect square. So our answer is the quantity 4x minus 5 squared. So this is what it looks like when you have a perfect square. Now, our last example had a or b subtracted from a. In this case, we're going to add a and b together. But it's a perfect square situation. So let's start out, take the square root of x squared, which will be x, and the square root of 9y squared, which will be 3y. And so that's our a and b. Again, you get two factors that are alike because we have a perfect square. So our answer is the quantity x plus 3y squared. Oops, here he comes again. Okay, here's our next example here. We have the difference of cubes. Now, instead of taking the square root of each term, we're going to take the cube root of each term. So in our example here, our problem, we're going to take the cube root of 8x cubed for our a and the cube root of 1 for our b. So 2x is a, 1 is b, substitute that in the right hand side and work that down, and we get the quantity 2x minus 1 times the quantity 4x squared plus 2x plus 1. That's what our answer would look like. Now this next example is adding two cubes together. What will our factors look like in the end here if we have a problem that looks like this? Well, we can take the cube root of each one of those terms, and we find that a will be 3x and b will be y. Substitute those into the right hand side and you get the quantity 3x plus y times the quantity 9x squared minus 3xy plus y squared. So you can learn to recognize some of these. Oh, I don't have to duck this time. Now, this is the last problem here. What we're going to do is substitute xy in for u. And this is going to simplify our original trinomial here. And we can go ahead and factor that in terms of u. And so when we do that, we get the quantity u minus 5 times the quantity u minus 12. Now substitute xy back in for u, and then we'll have our original trinomial factor. Thank you.